Cool. This should work now. So, um, yeah, I think thanks to the Twitter people, uh, I've been able to confirm that my intuition was correct in terms of like, uh, the way you map like qubits into sort of not qubits, but like your state vector into a tensor is by like you have one dimension per index or one index per qubit, right? So and then you kind of would have these gives you the complex amplitude of that element. Um, and I've seen Ryan LaRose basically shared these. This is just after the words. It's pretty awesome. So it's actually a full package. I haven't played with these yet, but it's a package for using matrix product states to simulate quantum circuits, and it even integrates to Cirq. So that looks really awesome. And actually, he shared a link to the concrete piece that creates like an MPS, right? And it's basically this part here. And so and what's more, it does this with qubits. It's not just qubits. Set the nodes on the interior. So I think that does it even better because what it does is it actually creates each of the nodes instead of just having something and then breaking it. Because I'm following more the concept here of you've got like something big and then you split it up. But here, I don't know if I can you, is this readable? It's probably not readable. Can I zoom that? So what is this doing? So I have no idea what is this. Good on two, but it's and qubits. Set nodes on the left and right edges. So it actually creates a node really with they're all initialized. It seems like they're all just initialized to the zero state. So what this does is it just probably creates that per amount of dimensions. I'm not familiar with this notation. But I guess that's the point. If I go and I just like I'll do it my way. So I'll do it like in a way where I just wanna break these down. So first reshape these. So if I ignore this for a second and I get these what if I do can I what is the way how can you with NumPy reshape? Just NP reshape and then the new shape. But I don't know what is it. Probably need to run this again. So that would just be like reshape and then I would give it like initial state and then it would just be shape like so It would just be basically, I'm gonna hard code it, but it's like, so the amount, the rank of the tensor would be 3, and it would each of them have to have 2 dimensions. Because in this case, it's a matrix of arrays. No. Let's see. And if we print that, if that makes sort of sense, because these would have to be then complex numbers, really. So what I probably want to do is I want to, there's a way you can do that, right? Yeah, you give it the type. So it's a complex number, an array. So you do that. So cool. And I now initial state print. Okay, so I get, so if I print initial state, for example, of the qubit, like of the element 000, it's these, yeah, and everything else is, so everything else basically has a component of like 0. So it's reshaped it correctly. How does this reshape happen? Like, does it do it in order? Probably does it in order. That's the way it does this. Cool. So actually, so that's it. And then if I now do like a if I basically create a tensor network or a tensor like node out of these, right? Tn node. Was it just Tn node initial state? And that's basically the initial node. And I do print these get tensor. I think I can do this, right? inode. Okay, there you go. So if I now, what I now want to do is I want to split these. So I want to do this. Was it like a so Google Tensor Network? And I want to do. I want to take a look at how did the symbol of the split. Was it the split node exactly? And we want a full, no, we want just these part, like split node without the full SVD. I'm not so sure if we want these or these, but like, let's just play with these for a second. So we have these. Now, this is the node we want to split. Now, the edges that we want to leave in the left and in the right kind of, I think it are the first 2 edges. I'm not so sure, but I would guess that's my guess. I don't know why though, but I guess I can just choose whatever I want. And if I print these 2 tensors, what do I get? An error. So what is the problem here? Unsupport operand types for plus edge and edge. So that maybe should be a list of edges, or maybe axes don't match array. What? It's just a tuple. Invalid syntax. What do I need to give it here? Or I should just get edges, maybe. Reorder edges. Well, I thought I could just refer to the edges. Documentation. Notes. Add edge. Get all edges. Get edge. Maybe just get edge. Something like this. It gives me the same thing here. So I don't think that's the problem. That's not the problem. Axes don't match. What the heck? I don't understand that. So what if I just print the edges first? Node. Get all edges. Get all edges. So 3 dangling edges. Yeah, kind of makes sense, right? And I just want to now split between the edge 0 and 1. Oh, maybe. Sorry, what I should do is probably inode. So just inode 0, and here inode 1 and inode 2. I maybe just have to include them all. Yeah, there you go. Okay, cool. We don't want to print this anymore. Okay, interesting. So now I have, this is this tensor. So this one tensor that's just alone, and it's got like all zeros. This means that is qubit. That's funny though. I don't know if that's the right way to do that though. Okay, but now we have these, and now if I wanna do that again, I would just do these with, say, these node, and basically now it just has two edges. So what if I call these guys, for example, Q0? This is going to be Q1, 2, right? And so, no, sorry, this is going to be Q1, 2, and this is Q0. That seems to be the way that it works. And so Q1, 2 is the one that's used here. This qubits 1 and 2, and then this is going to be Q1 or Q2, I think. This is going to be Q1. Exactly. And now I want to do Q0. So print the tensor separately, just to see how they look like. Can I just? I'm not so sure how this is being printed. So what this is printed like? So still that tensor that looks like pretty. Like there's a tensor there that is still like kind of not nice. Or that would be the one in the middle probably, right? Q0, which is just, and this would be the one in the edges, because those have rank 2 and this has rank 3. So I think I just got the numbers wrong, but it doesn't matter. So that would be Q1. That would be qubit 0 and 2. I think. Does it matter? It does somehow, because so if I print this guy here, it's actually the big one. If I print this one here, so they're both big. I'm not super happy with these. I'm not sure I'm doing this correctly. But I'm basically doing, yeah, because it should have a lower rank. So can I get like the rank of the tensor? Get rank. So, but that definitely get rank, print Q0, get rank 2 and 3. So Q0 is rank 3. Why is it rank 3 though? What's the rank of inode? That doesn't make any sense. Oh, because it's not connected. Maybe that's the reason. Sorry. So this would be this way. Oh. their rank. Oh, come on. It's 3. Yeah. Okay, but I should. Okay, so I should steal. So what I should do is I should connect. Yeah. I think I know what's going on. So I create first 2 parts. One has got rank 3, and another one is got. Can I just get a visualization of these? That's the first thing. Like. Graphical. Something like this. Common functions, maybe. Copy. Split node, split node, split node. Split edge, slice edge, check connected. Flatten edges. Cron. Can I just not like print stuff nicely? Doesn't matter. Okay. So where am I? So I'm trying to do split these. I'm trying to basically say I split this into Q2 and Q1 2. Q1 2 has rank 3. Why does this have rank 3? They should both have rank 2. No, one. So it's got one should have rank 3. Makes sense. Which is Q1 2. Cool. The other one has rank 2. So Q0 has been separated. Good. So now I take Q1 2. Which is rank 3, and what I want to do is I want to separate Q1 2 into Q2 and Q1. And if I print those ranks, Q1 should be the one that has rank 3, which kind of makes sense. Yeah. No. Q2 has rank 2. Q1 has rank 2. What? Am I seeing? Q0 has rank 3. Okay, so that's then the wrong naming. So I thought I had it right. So that's like 1 and 2. Exactly. So now Q1 2. Sorry. So now Q1 2 has the rank. But now so I should keep Yeah, that's what tells me. Okay, so I'm keeping these two dimensions, and this is a Q12 has rank 3. Q12 has rank 3. So if I now take Q12 and it has rank 3, what I want Q12 to do is to have exactly to have still these yeah. Now that makes sense. Okay, cool. So now I have what I want. The one in between basically kind of has three edges. Q1. So, and I think that if I what happens if I print Q1? What do I get? Oh, that's just an edge. Yeah. Get tensor. See, that's basically get tensor. If I can I just do that? 0, 0, 0, 0. So that's what we want. So these two are probably the ones that we should just. I don't know why I'm feeling that these two should be the ones that we're connecting the first two dimensions. Just because this is where I have. No, but that doesn't make sense either, right? Tensor and Q2 tensor, it's all like that. Yeah, I kind of feel like what we should do is how do I connect how do I connect the edges? Connect dangling edges. Okay, just with this sign. Connect just with this sign, right? Or is there like a connect? So what I'm okay, just use these. What's the how do you do this with the keyword? Oh man, that's bad. So what we want to do is we want to do is it just declarative like that? Okay, I actually have to get these edges. I mean, this edge 1 would be basically Q1 0 is connected with Q2 1. Or 0. And edge 2 is Q1 1 is connected with Q0 0. Can you just like print? I want to print this nicely in a sort of a graph way. But I guess there's no pretty print or something. Google Tensor Network. print graph or print network. Whatever. So get edges. So I want to get the edges of Q1. It's not a dangling edge. Oh, okay, so what's a dangling edge? Which is not a dangling edge. Oh, because they are ready. So that's probably, this is probably the way this works. No. So this is not a dangling edge. This is not a dangling edge. So the dangling edge. Oh, so things are already connected. That's what this is telling me. So get all edges. Okay, so we've got two. Yeah, that's the point. That's just the damn point. Q0's got one dangling edge and one connected. Q2 has got something's wrong. So I'm splitting. Okay, so I'm splitting. This is. I'm splitting. It's got two dangling edges and one connected to Q0. And after I split these, into Q2 and Q1, what I have is that Q2 okay, I get it. So this is the one we're living in the middle. So this should go this way. Oh man, that's tricky. Exactly. So you have two dangling edges for Q2. Q1 has, but I want Q1 to have one dangling edge. Why is this happening this way? So Q12 has 3. Q12 has 2 dangling edges. That can be that complicated. Come on. Q12 has 2 dangling edges. I feel like it's not my day today. And I want to split Q12 into 2 parts. I want to split Q12 into 2 parts, Q1 and Q2, in a way that maybe I'm just having the wrong dimensions in here. So Q112, it's got like a dangling edge. Maybe what I want to do is I want to just do it like these. Can I do these? But then I get the axes that don't match. Where does... Okay, so the one that is already connected stays here. That's what I'm doing. That's what I need to do. Yeah, I think so. So what I'm saying now is Q1 has got one dangling edge. Awesome. And two connected edges. Yeah, now we're talking. And Q2 has got like, yeah. Okay, perfect. Cool. Okay, I like it. So now we have the three nodes. So Q0, Q1, Q2. Those are the nodes. Okay, what I wanted to check now is how can I do a matrix product operator? Or first, we should really check Tn contraction. I think there's a way to just contract everything, like contracting auto. It's very easy. So there are all the nodes. Okay, so if I just do the result, so if I just do these, contract Q0, Q1, and Q2, and I print the result, what do I get? But the edge order has to be provided. What is this? Okay. When constructing a network with more than one dangling leg, you must specify the output order of the dangling legs. For instance, if you're only doing a partial network construction, then you can... okay, cool. So I can just set this to true. Get tensor. So I should get back my original tensor. Yeah. Okay, cool. Now what I want to do is I wanna. So this is basically MPS for these, but it kind of this is what's defeating the whole thing is that you kind of have to do these like that, right? I believe what I should do is I should take a look at these, and I think, yeah, I mean, they would just... So this is initializing a matrix product state for an all ground state, which is then probably easy because you can have all the qubits set to 0. So I think that's what this is doing here, basically, is creating those nodes and then just connecting. So it's just creating dummy dimensions, or dummy ranks, dummy indices, so to say, to connect the things. Now, what would be the MPO for like these, right? So this is the tricky part. So like the Hadamard So the edge gate is basically an NP array of like 1, 1, 1, -1 divided by 1 over the square root of 2. Is it? Is it like, is this the edge gate? Not divided, but like multiplied. What? SQRT. Oh, NP. So that's actually list of floats. How do I do this? Oh, it's an actual, so I actually, no, yeah, but that's correct. What if I just do this? NP array. Oh, that's what I was missing. Okay, cool. So that's the Hadamard gate. Now, good. I guess the idea here is like, if you think about like, let's see if I can open Paint here, right? If you think about the is Paint opening or what? If you think about the tensor product, what you're doing, right? When you're doing like the composition of like, say, the Hadamard gate and then the tensor product of another Hadamard gate, that would be the Hadamard gate applied to qubit 0 and the Hadamard gate applied to qubit 1. All what you're doing is you're taking the Hadamard gate thing in here and then basically putting this whole thing into like a bigger version of these, right? So you have like, and then you have the actual like Hadamard gate in here, and the Hadamard gate in here, and the Hadamard gate in here, and the Hadamard gate in here, right? So this nesting, right, is what you're basically representing by the contraction of like the two nodes that they have like dimension 1, and they kind of basically contract them and they become like a node with a two. It's not dimension is the wrong word. It's the rank, right? So intuitively, I don't know why, I kind of feel like each of those should be just a Hadamard. Like I have the feeling that each of those should be just a Hadamard, and then it just has like another index just like to connect stuff. It's an index that will just contract. So we could build it this way. I mean, actually, the operator is doing the wrong way. The operator should have these form. So it has these two indices which belong to the actual matrix, and then these other things are just like. But it's hard to grasp intuitively why this works at all. You know what I mean? So if I just go and say like, well, so I need like 3 nodes. So H1 is basically a node with like an H gate, right? No, that's also the wrong way to do it. because you want to have create these extra dimensions. That's what's tricky. Where's it? MPS. Oh, that's not. Where's the MPS? MPS. From wave function here. Actually, you have a from wave function method. Nice. Okay, there's a reshape. Perform SVD across each cat, exactly. Get all dangling, blah blah blah. So it does the whole thing. Nice. This is really neat, actually. This is the initialization, exactly. So it does basically like that. The Qt dimension. How would I? Oh yeah, and by the way, I forgot these. So I would actually say that, this is of time complex. But now, so this has got to have the node, the nodes at the edges, which is going to have 3 dimensions, right? So this means that it's just an array of a matrix. I think. No, what am I doing? So that's basically, if I print h1 care rank, what do I get? Type error. Class least. Oh, sorry. NP array. That's the way to do it. It's rank 3. Yeah, okay, cool. And actually, H2 okay, but this should have 2 dimensions. So actually I should do like these, just with this dummy 0. And so H2 will be the same. Get rank. Oh. Now it's rank 1. Why? Why does this make it rank 1? I should probably... That gives it... Yeah. So that should just probably be... just the identity, right? So 11001 complex. There you go. And so that should just be like the identity gate, should it? Yeah, kind of. Yeah. So that's the hard mode 0. And then the hard mode 1 would be... So the hardware one would be like here I need yet another dimension, so I just can I just do it like these? I don't know. Rank 4, but I don't know if that's. Let's try without these things. I don't know if this is gonna work. Sorry, this is H0, so 3 for 3 exactly. And what we want to do is we want to connect. So now we want to connect basically. So what if I do get edges? Get all edges. Get all edges. Get all edges. They're all dangling, so it doesn't really matter which ones we connect. I'll just say let's connect like the 0 with a 0 and then the 1 with a 0, something like these. So edge 1 would be H0 0 contractors, not contractors, connect. I forgot how to do this with the keyboard. So with H1 0 and then H2 would be basically H1 1 with H2 0. And if I now this works, cool. If I now print all the edges again, they should all be. Well, let's go ahead and say, like, if I now connect the qubits with the, like, if I now basically say connect, where's paint? If I now kind of connect these edges with the edges that are coming from the actual state, and I just do like a contraction, then I should just basically get the like a full superposition, right? Like an equal superposition. I hope so. So if I now go and say so we're going to connect. So we're going to connect. So H0 with, qubit 0. Can I do that? It's not a dangling edge. Sorry. H1 with. Okay, that worked. I'm going to connect basically Hadamard 1, the second edge with the qubit 1. That kind of worked. I really don't know if this is going to work out, to be honest. and H2 with qubit 2. Okay, interesting. And if I now do these, and I print the result, I contract everything. H0, H1. That's probably inefficient, but like doesn't matter, right? I just contract all the nodes. and print the result. Like, what do I get? Result. I want to have result get tensor, obviously. So I get all these basically 0.353. Like, how could I reshape? Like, can I just reshape these? NP reshape, right? These to have like the shape of like just 1/8 or something like that. Can I reshape? Can I reshape array of size 128 into shape? Why 128 though? Hmm. It's not exactly what I expected. What's the rank of tensor? Let's start from here. So print get rank 7. That's wrong. The rank should still the rank should be, so that's not contracting what I want. Why 7? So now, for example, if I print, say Q0, get all edges, shouldn't see any dangling, but I see some dangling. That's not good because I thought we're connecting them. Maybe I'm maybe I'm just using the wrong. So let me just remove all the prints. Dangling. It shouldn't have any dangling edges. Why does it have dangling edges? In this out of range. Dangling edge shouldn't have any dangling edges. But like even before these, right? Why Q0 has any dangling edges? What is it? It's got no dangling edges. So what the heck is going on here? It's got just one dangling edge. Oh, maybe because of these here. Yeah, I get it. So the contracting actually. So let's just comment these out. It seems if I contract, it actually really does the full contraction. So destroys the thing. So first of all, let's print these. And now what is it complaining about? In H4. Uh-huh. So that should be then 2. It's just trial and error. It's not a dangling edge. Then it should be 0. It's not a dangling edge. Why 2, 2? What is not a dangling edge? I hate that I don't know which one it's complaining about. If I print the dangling edges of Q1, it's 1. If I print it, oh yeah, now it works. Okay, in here it says of Q2, it's 1. Okay, so now this works. Awesome. And if I now again, I'm just really playing at the lowest level possible. No, like, not much automation here. Just really want to try to understand if this works as expected at all. If I contract the whole thing and result get rank 3, yes, that's good. And if I just do np reshape result get tensor, and the shape that I want is like a 1a, so sort of like going back to the state vector. Oh yes, that's beautiful. That's beautiful. That's beautiful. Oh, yeah. Because if I do 0.35 squared and I do 8 times these, yeah, should get close to 1. Yes. Okay, cool. Now, I don't like what I'm uncomfortable with is the fact that you can just like dummy out these dimensions here. But it's really worked for the MPO and for the MPS. Okay, cool. For 3 Hadamard, like, so my intuition here was right. Like you actually, so really each node corresponds to the operation that's going to apply to that particular qubit, and I find this really cool. I find this really cool. Yeah. Yeah, so now I think I'm kind of ready for the DMRG algorithm. I just need to understand how to approach the expectation value calculation, which I think it's this thing here. Basically, you're kind of multiplying, because at the end of the day, the expectation value, right? It's this like thing where you have like, your psi here, and then you have your Hamiltonian, and then so this portion is basically what we just did now in this video, and then this part is I think corresponds to this upper multiplication in here, and then it's just a matter of doing this sort of step-by-step approach where you're kind of, we're going to take our Hamiltonian, build an MPO out of it, and what we'll just be doing is, I think it's even easier this way. We'll just be kind of contracting. I think that's the whole point here, is that you're just contracting like sort of a subset of these MPO. So you're multiplying all these, and then you're getting these 2, and then you're doing this operation here. Yeah, I think I finally get it, but I think I need probably still a couple hours to get the full algorithm up and running. I don't know. That's probably not the most efficient um, way of doing it, but you kind of would get like the Hamiltonian. So would have to translate the qubit to the Ising Hamiltonian probably. Then build out the MPO, build a random MPS, and optimize that MPS. It's basically VQE, right? It's basically like yeah optimization. So um, but I'm still it's like the fact you can dummy these things out like and the fact that you can just like because as I say you could just as well create like okay let's try one thing before finishing this. What if I just say Q0 is a node with an NP array which is basically so so what I will do is I will say it's an array where it's a qubit that's in the zero state, right? So that will be it. But then it has how many rank? So the first should have just rank 2. So we'll just do it like these. Q1 would actually have another, and Q2 would just have like this one. And so then what we should just do is basically connect. What do we finish? Is 5, so it's going to be 6 and 7. So we're just going to connect like Q0, 1 with like Q1, 1, and then Q1, 2 with Q2, 1, say, right? So forget about all this stuff in here. So we're going to do this. Is this going to give me the same result? No, okay. Of an equal dimension. Dimension of edge was dimension 1. So I should maybe really dummy, but these things here seem to work. Oh, sorry. I think I'm gone. I think that should work. Excel range. No. No. I was right. This is the correct thing to do. But then dimension 1. Okay, I should just have like then basically a dummy here. Does this make sense? I'm not so sure if this makes sense. Index out of range. one with I can just create those empty, but then this needs another one. Yeah, I don't know. Maybe that was not like, but there has to be a way to create that this way as well. So not like, uh, mm, if I say that like kit 0 is the kit 0 is these basically, and now I go and I say, and I think that's what makes more sense. K0, K0. No, that's what's not working. The dimensions are not matching. Why? Yeah, something's like whatever. I'll try next time. It's not I think I'm not like going in the wrong direction, but yeah. Cool. At least it worked. At least it worked. Nice.